Socket outlet wiring explained. Radial circuit, ring circuits. Learning objectives. Understand the basic construction and terminal of socket outlet. Identify line, neutral and protective earth connection. Understand radial socket circuit and how loads are connected. Understand rings final circuit and the complete ring path. Compare radial and ring circuit wiring, protective loading and fault condition. Recognize common wiring mistake and essential safety checks. Socket outlet basic connection. Live line indicated L carries the supply voltage to the appliance connected to the socket L terminal protected by the circuit protective device. Neutral indicate from N. Provide the return path for the normal load current connected to the socket outlet N terminal must be correctly identified and terminated. Protective earth PEOE connect exposed conductive part to the protective provides low impedance fault path so protective device. Typical socket outlet wiring line neutral earth. Load the socket manufacturer terminal making and apply the wiring standard. Do not need to rely on it. Radial circuit. What is it? Radial circuit is start the distribution board and run outward to the socket outlets. This circuit not return to the distribution board to form a complete loop. Each outlet is connected along the same outgoing circuit path. Protective device rating and cable size must be selected for the design, load and installation method. Radio circuits are common in many residential and commercial installations. Simple concept DB socket 1, socket 2, socket 3. The circuit ends at the final outlet. No return connector from the final outlet to the DB. Radial circuit wiring concept DB, then socket outlet 1, socket outlet 2, socket outlet 3. Current flow from the DB through the outlets along the radial path. Ring final circuit. The ring final circuit starts at the distribution board, runs through the outlet and returns to the same protective device at the DB. The circuit forms a complete electrical loop. Current can reach the socket through either direction around the ring. Ring design is associated with specified wiring standards and design requirements. It is not simplify a better radial. Correct testing is essential to complete continuity and ring integrity. Ring final circuit wiring concept DB. Socket 1, socket 2, socket 3 again to the DB. The return path must be connected back to the same circuit protective device. Radial Vs Ring. Key difference. Circuit path. One way outgoing path. Complete loop return to the DB. Current path. One main load. Two possible directions around the ring. End of circuit. End of circuit. Final outlet. Return to the protective device. Device method. Depending on cable, load and installation. Required compliance with ring specific design rule. testing, continuity, insulation, polarity, earth fault check, additional ring continuity and end-to-end circuit connection tests. Common risk: overloading end of the long radial. Broken ring can change the integrity. How loads are shared. Radial. Protective device and cable are selected for the expected design current. As you move further along, radial voltage drop and cable must be considered. Ring. A load can be supplied from either direction around the ring. The design assumes the ring is complete and correctly installed. Important notes: do not assume any ring can safely carry any load. Cable size, protective device, installation method, diversity, and applicable standard determine the permissible design. Common short wiring mistake: reversing line and neutral at a short, leaving the protective earth conductor disconnected or poorly terminated. Loose terminal causing heating and arcing. Incorrect joining or mixing circuit neutral, especially where RCD RCBO protective is used, creating an unintended break in a ring final circuit. Using cable protective device rating without checking the installation method and design current. Working on an energized circuit. Isolation, lockout, tagout, throw-in dead are essential. Testing and verification. Visual inspection, checking enclosure terminal, conductor identification and mechanical condition. Continuity of protective conductor. Insulation resistance testing. Polarity verification. Earth fault loop impedance. Fault protective verification as required. RCD RCBO function testing via installed. For rings final circuit, verify continuity of each conductor around the complete ring and perform the required cross-connection test. Test. Testing should be performed with suitable calibrated instrument by a competent person. Choosing radial or ring. Consider radial when the ring suited dedicated final circuit. Cable size and protective device can be selected for the expected load. Simple circuit arrangement is preferred. Consider ring when the applicable wiring standard permitted and the ring specific design requirements are satisfied. Continuity and integrity can be verified. Always check design current, cable capacity, voltage drop, fault protection, RCD, RCBO requirements, installation method, applicable local regulation. These are the key takeaways.